Hi everyone, so today let's solve a Leetcode question called all nodes distance k in binary tree. Given root binary tree and a target node and integer k, we want to find all nodes in binary tree that have distance k from target node. And we can return this result in any order. Well, let's check example below to get intuitive understanding. And let me draw the graph here. Okay, so here we have the root node, which is 3, and then we have target node, which is 5. And we want to find the nodes that are distant 2 from this target node, right? So first, let me traverse from root to child. In other words, from top to bottom. So we try 25, checks left child 6, and this 6 distance equals 1, so not we want. And then 5 to 2, and also the distance 1, not 1. However, we found okay, 2 has 2 childs. One child is 7, one child is 4. If traverse 4, this 5 to 7 and 5 to 4, the distance would be 2. So 7 and 4 will be what we want. Now for the top-down approach, let's check back from bottom to top, which means we're checking from the child to the root. We'll check this 5 back to this root. Okay, this is 1, so now what we want. And then we found, okay, this tree had another right node, right child here. So if we go from this 5 to 1, the distance will be 2. So this is what we want. And finally, we check, okay, this one had 2 child, one is 0, 1, 8. However, the 5, the distance to these 2 nodes are 3, so this 2 node is not what we want. Therefore, the result array we want to obtain is 1, 4, and 7. Okay, I think by now you must get intuitive understanding on this problem. Let's think how to solve the coding part. Well, because the code in the question is very long, I think it's more than 15 lines. So I write the coding part before recording this video to help you save more time. Our intuition is first, we want to convert this tree to graph so we can traverse both from top to bottom and bottom to top. And after that, we want to run BFS search. So why BFS search here? So because we have to check all nodes that have distance to a specific target node, and we are not considering all the edge cases, all the top and bottom cases. So in this scenario, BFS search are more efficient and easy to understand in depth search. So how can we actually run the BFS search? The first step is to pop the node from the graph and we want to mark this node as visited. And after that, we will append all the valid node to results, then check its neighbors if their valid node is neighbors and return the result. Okay, now finish the integration. Let's dive into the real coding part. Well, first we have to initialize a graph in dictionary form so we can pass the key and the values. Here we use default dictionary function in Python so we can handle the missing key conditions easily. And then we need a VT set, we need DQ. So DQ is a first in, first out data structure. And finally, we need a result array, which is empty now. And after that, let's create an empty graph from the tree. So this help function is the bottom here. Okay, so the help function will pass the root, the parent node, the graph node, and if there's no roots, we just return none because if we're building an empty tree from to an empty graph, the graph will also be empty. And then we want to the parent node. The parent node, if parent nodes still exist, we want to append the parent nodes to the root node. And after that, we want to check all its left subtrees and right subtrees using the same principle as building the parent node. However, this is the question here. We have to pass the root or left and root or right recursively, so we can check the left and right childs at all levels. After we have converted the tree to the graph, we can safely search the nodes in 2 directions. Well, now the primary thing for us to append the starting node. Well, starting node will have the target node, and we also have the distance equal to 0, means okay, the distance from target is now 0. And after that, let's actually run the breadth search. So while there's elements in this queue, we want to first pop the nodes from this queue. So we pop this node with the distance, and we add this node to the visit set to mark visit. And after that, if our distance is exactly k, we want to immediately append this node value to result because this node what we want. And after that, we also need to check the neighbors, right? Because maybe some valid nodes in neighbor. So for all neighbors in this node, if the neighbor is not visited, we want to append this neighbor to the curve. However, here's one thing to note. Since we are traversing from node to neighbors, the distance are actually added by 1. So distance should be changed from this to this plus 1. And finally, we return the result array. This will be what we want. Okay, let's submit the result to see it works. Okay, you see the time capacity memory usage is very efficient for this solution. And although the coding part is very long, I think overall the logic is easy to understand, and the framework is just general breadth search framework. Okay, if you like this video, please subscribe to my channel, and I'll see you next time. Thank you.